This is R.D. Sharma Solution, Class 12th, Chapter 9, Continuity. VSAQ means Very Short Answer Questions. Define continuity of a function at a point. So, in a very normal language, if this is a road and if you are traveling and if you are reaching from point A to point B without any discomfort, without any breakage, that is called the continuity. But if the road is broken somewhere, you have certain problem, you have to change the route, so this is discontinuity. So in a graph, if the graph can be made without lifting your hand, that is supposed to be a continuous graph or function. But this kind of step function, these are discontinuous. Mathematically, the continuity is defined like this, that if you say that any point A in a domain means certain, domain can be minus infinity to infinity. So certain boundary is being provided. For example, from 5 to 9, just an example. That if you can check that it is, let's check at 6, when x is 6. Call this 6 as A. So when x is A, in this case x is 6, this function fx, this function is defined for say 5 to 9, then the limit x tends to A, that is x tends to 6 in this case. If we apply this limit on this function f, if you can say that x tends to A, fx is equal to fa. That is, if this function is x square plus 1, then we can find f6. And that is, or say f2. Any value, I'm just saying, it can be any value. It has to be, this f6 should be equal to limit x tends to 6 fx. Or if you take some other domain, limit x tends to 2 equals f2. So in order to check for 6, that is A, you have to go a bit behind, that is 6 minus h, and just a bit forward, 6 plus h. That is, the left hand limit and right hand limit should be equal, and that should be equal to the value of the function at that A. So limit fx, if you are taking left hand limit, you write x tends to A minus. If you are going a bit forward, limit x tends to A plus, that you have to find out, and that needs to be all these left hand limit and right hand limit, they both are equal, and they are equal to the value of the function at f or A. That is, the value of the function at A should be equal to the limit, and that defines the continuity of a function at that point. What happens to a function fx at x equals A? Now, limit x tends to A, fx is equal to fa. So what happens when fx at x equals to A? This is there. We have just seen the definition of a function. So this is the definition of continuity. So fx at A, certain value A, if the limit of this x when it tends to A is equal to the value of the function at A, that is fa. So this fx is a function defined in this domain. Sometimes the function can be like this. So that A point, that particular point where the limit has to be checked, that is, on the left hand you go, on the right hand you go a little bit, and if those both value, left hand value and right hand value, they are equal, and they are equal to the value of the function at A, that is the point we are checking, it may be a point of discontinuity because left hand limit, right hand limit are not matching. But if left hand limit and right hand limit are matching, and that is equal to the value of the function at A, that means continuity is there. Find f0 so that fx equals x by 1 minus under root 1 minus x becomes continuous at x equals 0. Now, if this is continuous, what does it mean? It means we have to check it at 0. So limit x tends to 0. This f function, fx basically, is equal to f 0, the value of the function at A is 0 here. So f0 is equal to the limit of the function at 0. Okay. So what do? This function is what? Since we have a root in the denominator, we can remove the root in the denominator by rationalizing it. How do we rationalize? X by 1 minus under root 1 minus x. We multiply numerator and denominator by the positive of it. That is 1 plus under root 1 minus x and 1 plus under root 1 minus x. That is what we are multiplying numerator denominator. Now what will be the benefit? The denominator will be, the root will be removed. So x into 1 plus under root 1 minus x. Denominator we have a minus b and a plus b. So it has to be equal to a squared minus b squared. So 1 square is 1 minus under root 1 minus x whole square is 1 minus x. So just write 1 minus x. So in the denominator you got 1 minus 1 plus x, 1 gets cancelled, x is there, x is in the numerator also. So you can just cancel these two and the numerator just have 1 plus under root 1 minus x. So this is fx and limit x is tending to 0. Limit x is tending to 0. So just apply 0 here, 1 plus under root 1, 1 plus 1, that is, it is equal to 2. So this is nothing but this fx at limit x tends to 0 should be equal to f0 and which is coming as 2. So f0 equals 2, the function fx becomes continuous at x equals to 0. If fx equals x by sine 3x is continuous at x equal to 0, then write the value of k. So x by sine 3x when x is not equal to 0, it is k when x is equal to 0. So if the function is continuous, we know, because we are going to check it at 0 in this case. So limit x tends to a in this case is 0. The value of the function fx limit is equal to the value of the function at that 0. A is 0 here. So limit x tends to a, fx should be equal to fa. A in both case is 0. So x tends to 0, limit x tends to 0. When we have x tends to 0, so x is not equal to 0. X is tends to 0 means it is not exactly equal to 0 but just near to 0. So we have to take x not equal to 0, so x by sine 3x. Now we know that sine theta by theta, limit theta tends to 0. What is the value? Limit theta tends to 0, sine theta by theta is equal to 1. So we will apply it here. So we have this x sine 3x, multiply numerator denominator by 3. And then you can take the limit. What you can do is you can bring this 3x down to the denominator. So you can write it as 1 by 3, 1 sine 3x by 3x. So this 3x we have the denominator. Now let's apply the limit. X tends to 0. Limit x tends to 0, numerator is constant anyways. So sine 3x by 3x you have sine 3x by 3x you have to apply the limit 1 by 3. Limit, the numerator will be 1 and denominator will be sine 3x by 3x, that is going to be 1. So numerator is 1, denominator is 1, only 1 by 3 is remaining. But by the definition of continuity, it has to be equal to f0. This is when f0 is what? When the value of 0, when x is 0, it is equal to k. So f0 is k. And what is the limit? We just found it to be 1 by 3. So k has to be equal to 1 by 3. K should be equal to 1 by 3. If the function fx is equal to sine 10x by x, x not equal to 0, is continuous at x equal to 0, find f0. Okay. Now same way we will proceed like this. It is sine 10x x. So limit x tends to a, fx should be equal to fa. What is a in this case? It is 0. So limit x tends to 0, f x is equal to fa. A is in this case is 0. So we have changed this a to 0 because in this case we have to find out for 0. So sin 10x by x will take the limit. So multiply numerator denominator by 10. Okay. Now apply the limit. You know by previous question also, sin theta by theta, limit theta tends to 0 is 1. So take this 10 outside, apply the limit for this, limit x tends to 0. So x tends to 0, 10x is also 0. Limit theta tends to 0, sin theta by theta will be equal to 1. This whole is 1, you get 10. So this is equal to what? F0, Fa or F0. This is your F0 and this is going to be equal to 10. This is your answer. If fx is equal to these two functions, one is the constant, when x is not equal to 4 and x equals 4. So this is continuous at x equals 4. So we have to find k. So what we have to do here is, we'll just take the limit. Let me tell you once again, just to recall, that limit x tends to 4, x square minus 16 by x minus 4. This should be equal to F4. F4, that is FA. What is F4 here? When you put 4, you get K. So whatever is the result, that will be equal to K. So we have to essentially solve this limit. So x square minus 16 can be written as x square minus 4 square by x minus 4. X minus 4, x plus 4, a minus b, a plus b. X minus 4 in the denominator, you can cancel this out, x plus 4 is there. So limit x tends to 4, x plus 4, and just apply the limit. In place of x, just replace it by 4. 4 plus 4 is 8. So k is equal to 8. Determine whether this fx, the point of contention is 0. So it is not equal to 0 sin x square by x, 0 when it is 0. So whether it is continuous or not at x, that we have to find out. So if it is continuous, see, limit x tends to a, in this case we have a as 0, sin x square by x, this has to be equal to fa, a is 0. So this is equal to f0, and f0 is what? When you put 0, it is already given in the question, it is 0. So we have to solve this. Sin x square by x. So multiply the numerator and denominator by x. Why? Because we need x square in the denominator. Because we know what is the limit of sin theta by theta when limit theta tends to 0. That is limit theta tends to 0, sin theta by theta. So sin inverse is also same. I'll just tell you in the coming question. So let's apply the limit. Theta tends to 0, sin x square by x square. When x is 0, x square will be equal to 0. So you can also say limit x tends to 0. But here we have this x is extra. Limit x tends to 0 because we have by ourselves introduced this x. 1 into 0 is 0. Okay. So what do you get here? This is continuous at x equal to 0, but because it is equal to f0. So this is how we are going to write. Okay, the logic I gave you, but the writing is on the left hand side which I showed you. If fx is this, when x is not equal to 0, when x is equal to 0, it is going to be k, and this is continuous at x equal to 0, we have to find k. So let me give you again the definition for continuity. Limit x tends to a, this fx, if it is equal to fa, a is 0 here. So this will be the condition for continuity, necessary and sufficient. So limit x tends to 0, 1 minus cos x divided by x square. Fa is what? F0 is what? It is k. It is already given in the question. So whatever we solve here, that we will equate to k. 1 minus cos theta is what? 1 minus, actually it is 1 minus cos 2 theta is 2 sin square theta. But since we have this 1 minus cos theta, we can write it as 2 sin square x by 2. In the denominator you already have x square, which you want. But we need 4 in the denominator, so we multiplied the 4 also. So I am just taking this 2 by 4, which is half outside. Now limit, what do we have? This is sine x by 2 and divided by x by 2 and this whole square. Sine theta by theta whole square. So sine theta by theta we already told you just now. Limit theta tends to 0, sine theta by theta is 1. So you have half and this is equal to k. So this is on the left hand side. I showed you actually how you have to write everything. If fx equals sine inverse x by x. So before we go ahead in solving this, limit x tends to 0. This is sine inverse x by x. This is equal to 1. Okay. So the definition we already know. So limit, I'll directly write a as 0 here. So limit x tends to 0, sine inverse x by x, and this is equal to f a is 0 in this case, f0, and that is given in the question as k. So k will be equal to sine inverse x by x, limit x tends to 0. And I told you already it is equal to 1, so k is equal to 1. Write the value of b for which this function fx is continuous at x equals 1. So if you make a number line, you see there are 2 points here. Actually 3 points, 0, 1, 2. So 0, 1, if you go to the left of 1, 1 is inclusive in 5x minus 4. So the function number 1, which is 5x minus 4. The second number function, if you go just ahead of 1, you will take 4x square plus 3bx and below 2 of course. So the point of contention of continuity checking is 1. So we'll find out the limit, left hand limit, right hand limit. We'll equate them and then we'll equate it to the value of the function at this 1, f1. So LHL, RHL. So this will give you continuity along with the value of the function at 1. So f1 I am talking about, right? Okay. So let us check this, and since the point is 1, so f1, before going ahead, f1 is what? Where is the equality sign? It is at 5x minus 4. So just put 1 in place of x. So 5 into 1 minus 4, that is going to be 1. f1 is 1. So LHL, RHL will equate it to 1. Okay. Let's find out LHL. Now since the point is 1, so we'll take left hand side. So 1 minus h we have to take. Right hand side we have to take 1 plus h. So x is equal to 1 minus h on the left hand side, 1 plus h on the right hand side. This is left hand limit and right hand limit. We are just going just a point below and above. It's just h, which is very small, equivalent to 0. So I'm replacing this 1 minus h in 5 into 1 minus h minus 4 because we have to take the first function because we are going on the back side of 1 or behind 1. Let us apply the limit. Limit h tends to 0. 5h is 0. 5 minus 4 is 1. So left hand limit is 1, which is equal to f1 also. Right hand limit. For that we have to use 4x square plus 3bx. This function we have to use. So 4 into 1 plus h whole square plus 3b 1 plus h. So 4 a square plus b square plus 2ab 1 plus h, 1 square plus h square plus 2h plus 3 into b plus 3 into b into h. So 4 plus 4h square plus 8h plus 3b plus 3bh. Now just apply the limit. Wherever h is 0, just you can remove that term. You get 4 plus 3b. Okay, this is right hand limit now. Now this left hand limit and right hand limit we have to equate. So let us equate it with 1. So 4 plus 3b is equal to 1. So 3b equal to 1 minus 4. There is minus 3. B is equal to minus 1. B is negative 1. This is your answer because B has to be found out. This is how you have to write, okay? Determine the value of the constant k so that the function f, x and fx is given like this. Kx by mod x if x is less than 0, and if it is x greater than or equal to 0, it has to be 3. So what is the way? Left hand limit, right hand limit equate with the value of the function at that particular point, which is 0 here. So left hand limit, right hand limit, right hand limit we won't be finding because it is already a constant 3. That is, if you have 0, left hand limit, you will take kx by mod x. But right hand limit, it is already 3 because at x is greater than or equal to 0. It is 3. And what is the value of the function at 0? It is already given as 3 because equality is x is greater than or equal to 0. That is at 3. So x is mod x is x greater than 0 minus x if x is less than 0. So left hand limit we will find out, or you can say just limit we will find out. And good to find out the left hand limit. X tends to 0 minus, or you can say 0 minus h. X equals 0 minus h will put. This is how we write. So this is k into 0 minus h divided by 0 minus h. This is I am replacing. So x is less than 0 is what? We already know x is less than 0. Mod x will be negative x. Okay. And since we already are using this 0 minus h with modulus, numerator will be minus k into h. Denominator will be, since it is minus h, the modulus will always give you a positive sign for a negative 1. So it will be h. Now you can cancel this h out. You will get a negative k. So limit h tends to 0. So minus k it is. Okay, what is this equal to? 3. As I told you already, it is equal to 3. So this is equal to 3, k is equal to minus 3. This is your answer. But you have to write like this. On the left hand side you see the solution. Find the value of k for which the function fx is equal to this. Is continuous at x equals 2. So it is very clear here that is continuous at x equals 2. So we are talking about a point 2, and since it is not equal to 2, so you don't have to go for LHL or RHL because you just have to find out the limit. So we will just find out limit at x tends to 2 for x square plus 3x minus 10 divided by x minus 2, and we have to equate it with k. It is equal to f a is 2 here, f2, and question is saying when x is equal to 2. Actually this is x equals 2. So this is already given as k. So whatever is the solution of the limit will equate it to k. Let us solve this. So we'll write it as, I am making the factors, x square plus 5x minus 2x minus 10 divided by x minus 2. So x square, you can take x common, x plus 5 minus 2 x plus 5 divided by x minus 2. So x minus 2 x plus 5 by x minus 2. You can cancel these two, x plus 5. So limit x tends to 2 x plus 5. Apply the limit 2 plus 5, and this is equal to 7. So k is equal to 7 in this case. This is your answer. You have to write like this. On the left hand side you see the solution, right? Okay, this is all about this VSAQ. Thank you so much. Take care of yourself.